But on the slides, it says that it does not move longer.
It, wait a minute,
It moves along the one.
action potential. Right, the action potential from the nerve arrives at the area where the nerve meets the fiber. So now we've got to make sure that the way that we get that muscle to contract is that we pass along the information. And the passing along of the information is going to be the movement of the ions back and forth. So it's not like every single sarcomere point gets the action potential. Action potential only comes in at one point. And then we've got to move it. It's got to spread along the fiber. Does that make sense? Okay. So we're going to be dependent on our gated channels. Okay? So now, when we have the action potential arrive at the point where the nerve and the muscle meet, we're going to find in that area ligand-gated channels. So if I think about the nerve meeting that fiber in this area right here where they meet, okay, I'm using ligand-gated channels. But I still have the rest of this muscle fiber that has to be affected. Which one am I going to now be dependent upon away from this point of contact? My voltage gated. Okay? So at that point, ligand gated, voltage gated, change my voltage back and forth. Okay? And then I'm dependent on my sodium potassium to bring it back to rest. Yes, no, maybe. All right, so the gated channels are going to become important. Now, the way that we get to move this potential, the propagation, okay? So, let's say that along my fiber, okay, I've got the point where the nerve and the fiber meet. And I've got all my little ligand-gated channels. And they get ligands, okay, they get a chemical, and therefore the positive on the outside gets to rush in. It rushes in at my ligand gates, okay? We change the voltage, but now I've got the whole rest of the fiber to deal with. So let's look at what's taking place. At the point of where it begins, well, it made this section more positive, which means it affects voltage gated here. So the voltage gated here opened up, let it be more positive. Well, that affects the next little section. So the next little sections, voltage gated, open up, make it more positive. And then if we were to continue having the picture go along, okay, this little section right here would be affected, making it more positive. And then this one would get, do you see what I'm talking about for propagation? All right, and we simply pass that along. Now, look what's happening to the section previous. What do you see about the charge in the section previous to the one getting changed? It's going back to being negative because I've got my sodium potassium pumps trying to get the stuff back out so that I can turn this back to being more negative. And I pass that potential along the fiber. propagates, moves. Yes, no, maybe. Okay? So how does it all get started? Here's how it's going to get started. At the point where the nerve and the muscle meet, this is called my neuromuscular junction, my NMJ. So that tells me that in this area around this nerve, that is my area where I find my ligand-gated channels. Everything else along this fiber is our voltage-gated and our pumps and leaks and everything else. Is everybody with me? Now, the neuromuscular junction, pretty specific, okay? Telling me a nerve, telling me a muscle. So this is the point where the nerve and the muscle meet. The neuromuscular junction, what we end up getting, we get this synaptic cleft. We've got the nerve coming in, nerve come in, branches to meet all of our little fibers. So as it meets a fiber, it kind of does an invagination, okay? And we form a synaptic cleft. The only thing that a cell can produce as a product, okay, is a protein. So the little filled vesicles, the product of the nerve, is going to be a neurotransmitter. In the case of muscle contraction, our neurotransmitter, the chemical, is acetylcholine, ACH. That's it. That is the only neurotransmitter for muscle contraction. So the terminal bud of this nerve is full of these little vesicles that are going to secrete the neurotransmitter. The invagination on the membrane right here of the muscle cell, okay, from this point around, this is going to be full of the ligand-gated channels. And it's going to be a shape that accepts the acetylcholine. So if the acetylcholine gets released, all right, if we get release at this neuromuscular junction, and if we've got the ligand-gated channels that are present, the acetylcholine gets to attach to this area on that channel protein, and when they attach, the gate opens and our sodium gets to rush in. So at the point, all right, of that neuromuscular junction, there would be tons of the ligand-gated channels. And if we had the release of all of this acetylcholine, and then all those gates open, and all that sodium rush in, well, what do you think is going to happen on the other sides of this area that we have? Which ones are they going to open? going to open the voltage gated. So once we have the release of that neurotransmitter, once we have the release of the acetylcholine, and we open all of those gates and all of that sodium rushes in, and we now begin to have the effect on the voltage gated, we're going to see those open up, sodium rush in, and we're going to go from being negative to positive. And if it's happening to enough fibers, the muscle will contract, because we'll definitely reach threshold, and once we've done that, that muscle's going to contract no matter what. Then sodium-potassium pumps will come in, balance everything out. Now, let me think about this for a second. At this area of the neuromuscular junction, where the acetylcholine is going to be released, do we need acetylcholine to stay in that cleft? Would we want acetylcholine to be constantly present in that area of the neuromuscular junction?
No.
Why?
Because it's going to keep stimulating the muscle.
And the muscle cannot withstand a prolonged period of muscle contraction. So we need to make sure that the acetylcholine that got released, okay, the acetylcholine gets broken down. So guess what we have? We have an enzyme, acetylcholinesterase. Say that a couple of times, okay? Acetylcholinesterase. And that comes in, breaks down the acetylcholine. Some of it goes back into that terminal bud of the nerve. Some of it gets taken care of in the bloodstream. And then the whole process will start over again when we get another signal from the nerve. Yes, no, maybe. Pretty cool, right? But now at this point, have I said anything about the actin and the myosin in the area of the sarcomere, which is the functional unit of the muscle fiber? Let me think about that for a second. At this point, I've only shown how we can get the sodium into the cell to make it change polarity. Oh man, what else is going to have to happen? Right? Seriously. Okay, yeah, some other things are going to happen.